Hello, I'm going to present Monolith Modularization towards Microservices, Refactoring Performance and Trade-offs. This is the work of Nuno Salves, Diogo Faustino, António Rui de Silva, and Manuel Portela. I'm António Rui de Silva. So what is the context of this work? We are working in the context of the migration of monoliths to microservice architectures. And we want, in this work, we start thinking about study what is the impact of this migration in terms of refactoring the code and performance. But when you look at the related work, we have realized several aspects. One is that there's not a lot of work in terms of the development effort. So people describe how do you migrate your system to a microservices architecture, your monolith to a microservice architecture, but usually it's from the perspective of the product, the functionalities, not the development effort. And as well, what are the required refactorings? On the other hand, when you look at the work on the comparison between the performance between monolith and microservice architecture, we see a lot of different aspects. So not really structured. So it's really difficult to compare the work because there are variations on architectural decisions, variations on the technology. So it's really difficult to compare. Because of that, and because of all these variables that occur in this process of migrating a monolith to a microservice architecture, we define a strategy. Well, why not just analyze the migration of a monolith to a modular monolith in terms of the refactorings and the performance, and see in this first step that actually is a necessary step when you migrate a monolith, because you need to define the modular structure. So you need to identify what are the modules and define the borders between the modules and the interfaces between the modules. So if we study what has the impact or what are the necessary refactorings and the impact on performance, you can have already some idea and some data about what happens. So then you can move from the modular monolith to the microservice architecture, but this is another step. So how do we see the modular monolith? Basically, we define modules with interfaces which isolate the domain module. And the interactions between modules, we define two types of interactions. Uses interactions, with basically one module knows that the existence of another module and invokes in the interface and obtains data from it. Usually the data that obtains are data transfer objects, so you don't share domain entities, because actually domain entities are isolated and encapsulated inside the module. And another type of interaction between modules is the notification interaction, where one module notifies something that occurs and but doesn't know, so just a publish subscribe interaction, doesn't know who's subscribed to this. The reason because we define these two types of interactions is basically to avoid to have circular dependencies between modules. So we define core modules that actually everybody knows about, and module, and that when something that is relevant occurs inside this module, they just send an event through the notification interaction. So we applied this to the L2D, which is a digital archive of the book of Disquiet by Fernando Pessoa. This is a Java Spring Boot application. It has 152 controllers, 55 domain entities, and around 30,000 lines of Java code. Okay. We have several modules inside. So we have here we list 7 different modules, and we pick these modules and actually start. What we have done is just to start isolating them and defining interfaces around them, uses and notification interfaces. So this is just a a portion of the total model. As you see, the type of model we have here is a strongly connected model with bidirectional relationships between the domain entities. So in the first point, this simplifies a lot the development because actually it's very easy to obtain data. So you just need to go through this graph of objects and invoke whatever you need. But after a while, it becomes more difficult to manage because actually there was a lot of complexity associated with these large domain models. And when we identify the parts that we the domain specific parts that we are going to define the modules, we define two types of things. One is entities that here are in these colors, not the gray color, but the other ones that are entities that belong to a particular module. And the gray ones are entities that actually belong to several modules. So you see that you have all types of relationships between these domain entities. So what was the first refactorings we have done? The first one is that we identify some God classes. God classes are these classes that actually belong to different modules. So the main refactoring we have done, so in this case is the L2D, which actually is a singleton that is the entry point of a lot of most of the functionality. And in this case, the refactoring we had to apply was to split these God class into several classes, one for each one of the modules. Another refactoring that was relevant was inheritance trees across modules. Here you have edition and frag inter that actually are classes that belong to two modules. What we have done is actually we just apply the refactorings associated with remove superclass. So first we move the data and the business methods from the superclass to the subclasses, and then basically we remove the superclass. And the next refactoring we found was the relations, the associations between domain entities as represented here between the Scholar inter and the virtual edition inter. And to do that, what we have done basically now, instead of, so in the previous one, when the virtual edition inter needs to interact with the Scholar inter, just invoke a method there. But now you want to avoid this because of modularity, and then you need to define an interface. So in this case, this part is part of the test module that basically is a core module and doesn't know about the virtual model. So it notifies, so it sends events. And the virtual module may invoke these interfaces. What happens here is that you are not going to change domain entities between them. You need to define data transfer objects that just send the data to be used in the so for the interaction between the modules. And associated with data transfer objects, you need to have unique identifiers in all external identifiers in all the domain entities that are known from outside. Because actually, when this module needs to know the data of Scholar inter, for instance, it needs to have an ID of Scholar inter to ask this module, please send me a data transfer object with the ID, with information of Scholar inter. So we have done an evaluation of this refactoring, and we realized that in terms of modified entities for each one of the modules, this value can be very, very large. So in text, 55% of the domain entities have to be somehow changed. And in virtual, 82% of the entities had to be somehow changed. This is because actually even if the entities are not in the border between the modules, actually you have the Demeter law that says that actually you send references of these entities between inside the module. So there are entities that actually do not know or do not have an association with domain entities of another module, but they receive a reference of and interact with them because they see a reference through an invocation parameter. Another thing that you measure is the total number of domain data transfer objects that was necessary to define. And we realize that is also high, so 25% of the domain entities in the 24% in the text module were necessary for them to define domain objects. Okay, for instance, in the virtual we have 41%. And then you also measure what was the modified relation. So in the sense of modified relations, it was relation that continued to exist, but at least one of the entities that were involved in the relation, in the association, changed. And removed relations was basically the relations that actually completely disappear, for instance, when they are in the border between two modules. So, and then we move to performance. And we just, after the first migration, we just have done, we realized that we had to define a lot of data transfer objects. And we measure performance, and the performance was not acceptable. So, because of that, we defined a couple of associations. One was to associate a database access index to the unique identifiers of domain entities that are exported to other modules. Why? Because now, since you don't have these, every time one module that uses another one needs information about a domain entity, so needs to get a data transfer object about that domain entity, he is going to use its unique identifier. So there's a lot of operations now that is just give me the data object for this unique identifier. So we need to define indexes to access the database so that this is improve this access so that you can just so improve the access so it's much faster to get the object from the database, because this become quite frequent. Another one is whenever a data transfer object is generated, we just by default load all the values of all its attributes. So basically we realize, firstly we just define some type of lazy objects that you just, when you get a DTO, you just load the attribute you need, and then when you need more attributes, you just keep loading the attributes that were missing, the values of the attributes that were missing, but then this results in a lot of intermodule invocations. So by default, and this really improves performance when you apply this. And the last one is in a few cases where actually when we invoke, we invoke to get data from another module, you need more than one object. Actually, you need a tree of objects or a graph of objects. In some cases, after we measure the performance, we realize that it was necessary to get this fat domain object that actually contains not just the information about these fat data transfer objects that contains not only information about one domain object, but contains the information of several, a graph of domain objects. So we pick 4 functionalities. These are the 4 functionalities we pick to measure the performance. Source listing, fragment listing, interpretation, view, and assisted order. We pick them because they are different. Some of them really required a lot of information. Some of them, but actually only access one module. Okay, so it's from the front end to the text. For instance, this one. Others actually access a lot of different modules, so correspond to a lot of interactions between the modules. Others do, for instance, like assisted ordering, do a lot of computation. So, and actually we measured the performance of this. So the way to read this is that this number is the monolith, the performance for the source listing functionality in the monolith, the average time, the latency, when you have 100 fragments in the database. This is when we have 720 fragments in the database. Okay, and we'll see here that if you have more data in the database, the performance gets much worse. So this is strongly related with this DTO, so the transfers of data, so creating the DTOs and sending the data transfer objects between the modules. In other cases, we have interesting results that you get even better performance in the modular than in the monolith, like in these cases. And we checked why it was like this, and we realized that it was related with these indexes we defined to access the domain entities in the database, given its unique identifier. Why? Because before we do much more we usually go through the domain objects more frequently to get an object instead of just doing a query to get it from the database. But actually then when you increase the number of data, so when you move from 100 fragments to 720, you get yes, the performance is worse in the modular than in monolith. Another thing here, we'll see that, for instance, in this case, where actually you don't need a lot of information, the data transfer objects. In this case, even the performance improved a little bit. Okay. Another thing that we can observe is the relation between latency and throughput. So they are correlated. Okay. And finally, in this case, assisted order, where you do a lot of computations, actually it kept the same independent of the number of fragments that are in the database. And the reason for that is that already in the monolith, because we had some performance problems here in the monolith, we already have a cache. Okay, so we take advantage of the cache in the modular monolith as well. So some conclusions. The migration of a monolith to a modular monolith requires a significant amount of change in the code. Data transfer objects significantly impact on performance. The impact on performance varies with the characteristic of functionality, and the impact on latency is correlated with the impact on throughput. So I think that this gives a first idea about this migration from microservices, from monoliths to microservices, and show us that even without having a distributed context, we already need to be concerned about the migration effort and performance issues. Okay, thank you.